Hi, welcome to Cutting Tool Engineering's Bourbon with the Editor podcast. Here again with Vargus USA, senior, I shouldn't say that, applications engineer Will Nash.
Hey.
And special guest here joining us today is Aaron Kolb, an instructor in the advanced manufacturing program over at Harper College. And that's right here in the suburbs of Chicago. So we are going to be we're going to be talking about, part two of our pump shaft design and machining, this replica part, the sample part for oil and gas industry. But first, we're going to show off the Blantons that we're going to be drinking tonight. And it's basically a 93 proof Blanton's. We've had this before on this podcast, so it doesn't need a big backstory, but it is a very good bourbon, and I'm going to have this one without ice because I already know it's good and not too strong. And if you can't tell, these are collector's items. There's a different horse for every initial or every letter of their name. So Blanton's, if you like this bourbon, you can collect all 8 or 6 or 7 bottles, whatever it is. So here we go. Cheers to you guys.
Cheers. Cheers.
Cheers. Let me get back to my chair. Oh, you know what? Before I do that, let me just swing this back your way.
Thank you.
That's good. Oh, okay. Now I'm in the spotlight again. So, welcome everyone. Thanks for joining us. I'm sorry we're a little late getting started. We're just want to make sure we had everything ready to go. So, we've in the first portion of this, just in our last episode,
Yeah.
we covered the lathe machining that we were doing for this sample item. And this time we're going to be talking about the CNC milling that was done for this part.
Correct.
And we again went to Harper, and Aaron helped us machine this. We had help from, obviously, Will, Vargus, and Alacona was helping involved in this, in measuring the part after it was done. And this software that was being used, the CAM software, was Hypermill. So they're all involved in this, but I'm going to ask you to go ahead and get us kicked off here, Will.
Yeah, sounds good. Thanks, Dennis. I'm Will from Vargus, right? And Tim, maybe if you could bring up the print for a moment here, we can just talk about what we did. As Dennis stated, the last episode was all of the turning operations. So if anybody's tuning in tonight and hasn't watched the turning operations, we did all the preparatory work to get ready for the milling operations. We did the threads, we turned everything to size, we did the grooves. And that's a very interesting episode in and of itself, but tonight we're going to be talking about again the milling operations. So we have 3 different operations to discuss, and some different programming strategies and things like that to go through, and the cutting tools, of course, that we used to get those operations completed. Obviously, during this time, we were at Harper College. In the Advanced Manufacturing Laboratory. Am I saying that right? Is it a laboratory or what?
I think officially it's a laboratory,
Okay.
but it could be just as well a shop.
Okay.
Yeah,
So Aaron, you're responsible for that shop?
I am. Yeah, I am. I'm an instructor in the Advanced Manufacturing program. I teach primarily CNC, manual machining. I do teach a welding class here and there, but yeah, I've been at Harper now for 10 years. I've taught all the classes. We have not only the machining classes, we have quality classes, we have some dimensional metrology classes, and of course safety is a big part of the manufacturing industry. So we have some classes in that as well.
Okay. Okay. And I'm just curious, approximately how many square feet do you have and how many machines do you have in your program?
Square footage, I'd have to estimate. Our primary lab is probably close to 10,000 square feet. And then we have another small lab that just has manual machining, and we do some maintenance classes down there as well. That's probably another 1,500 to 2,000 square feet. So
Okay.
it's a pretty decent. It's a pretty decent space. It's pretty full. As far as CNC machines, with our new additions, we have, I believe it's 11 or 12 CNC mills and lathes. We have a full welding lab. I believe we have 43 welding booths. We do all the processes. And then our manual lab, we have, I think it's 12 Bridgeports. I think we have mills. I think we have 7 or 8 manual lathes. We have an assortment of drill presses and surface grinders. So we try to cover, a wide variety of all the processes.
Okay. And I think for me, that's really important because, a lot of shops I go to, the newer shops, they have advanced technology, but not every shop does. Some shops still have, 15 and 20-year-old CNC machines.
Yep.
But every shop I've been to has a Haas, or sorry, maybe not a Haas. They have a Bridgeport and like an old like engine lathe
Yes.
in the corner somewhere, right, where they're using for whether that be their tooling department or something. They have a couple of pieces of manual equipment for those kind of operations.
Yeah, absolutely. And I tell my students that you're going to be kind of a leg up on other people that don't know how to run this stuff. It's amazing the pushback I do get from certain people that don't see the value in teaching, the old manual, kind of the manual way of doing things. And so not only do I think it's important because, like you mentioned, the shops do have those machines, kind of sitting there. But for the students to learn on that first and learn all the fundamentals, because you're literally feeling the machine cut and you're turning the dials and everything. To me, that's where the fundamental principles are learned, and it makes the CNC, that education portion of it, so much easier.
Okay.
Because now we're just talking about numbers
Yeah.
and how we put them in the control, but they've already got the feeds and speeds down. We've talked a lot about fixturing and how you hold the part, and I feel it's a lot harder for the student to learn that going to the CNC. All the CNCs are enclosed, so you can't. It's, to me, that's another world inside that enclosure, and
Yeah.
you can't. It's hard to see and hear what's going on if you haven't already experienced that, like, kind of almost in your face.
Yeah.
So I do think it's really important. That was one of the things that kind of drew me to Harper in the program, is how they had things set up. And it's amazing in the Chicago area here, because we are still one of the areas that have more manufacturers per square mile than, a lot, I'm going to say most, if not any other place in the country, at least where we are located here in the northwest suburbs, where they call the Golden Corridor. And there are still shops. There's people I've spoken to recently, like this year, that, they've got anywhere between 15 and 40 machines, and they're still all manual.
Mm-hmm.
All manual. And I actually spoke with a gentleman back in August, and he's worried because he doesn't know where he's going to replace the people he has. He's got a very specialized business, and he goes, I just don't foresee us going into CNC at this time because we've done so well with what we have. But he
Yeah.
goes, the kids coming in, they don't want to learn. They don't want to run a manual machine. But
Yeah.
he said, my guys are being paid anywhere. He said I think he has, I don't remember exactly, 12 machinists, and I think they're all being paid between $40 and $65 an hour.
Yeah.
So that's not a bad wage for a manual machinist.
Yeah, I mean those are those are true machinists though.
Yep.
And there's unfortunately not a ton of people out there with the skill to make a setup on their own, to get a machine ready on their own, and then to run parts effectively, right? So
Yeah.
that's why those guys can command that salary, right? They're true machinists.
Yeah, no, I agree.
And it is unfortunate that in a lot of ways the industry has gone towards separating out the roles. So you've got, maybe setup guys, you've got, operators, you've got programmers, and the job that used to be one guy is now 3 people with various levels of management in between them,
Yeah,
right?
correct.
But I mean, we can get into that maybe a little bit later. I guess I would like, Tim, if you can bring up slide 2 for us so that we can see the print for the part that we were working on. So if you missed episode 1, this is the part that we're making. You can see that there are some keyway slots in here, a couple of flats, maybe indexing flats or wrench flats, whatever you want to call them, and then there's an SAE B spline on there on the end. So those are the operations that that we're going to be talking about tonight. And then if we go to the next slide, we can see the tooling. So this is all of the tooling that we had for the entire project. All of the cutting tools were supplied by Vargus. So we have some different turning tools, threading tools, drills, end mills, spot drills, shell mill here, and we'll get into the specifics of the tooling that was used for the milling operations here a little bit later. Aaron, you've already introduced yourself, but
Yeah.
on slide 4, Tim, we've got some contact information for anybody who might be interested in attending Harper or getting some of the knowledge that Aaron has. And I mean, you guys are a full-on college, right? So you offer associates programs
Correct.
in a lot of different fields. It's not just manufacturing. So somebody who's interested, for instance, in computer science could contact you guys too, right?
Correct. And we have a
Okay.
transfer program for engineering, and we have pretty much anything that you'd like to do. Again, we're a 2-year college, community college, but we, like our program specifically, we have articulation agreements with, I believe it's 4 or 5 different universities where they will accept our associate's degree as a whole, and then the students can be accepted into various 4-year programs. Like there's some engineering management. I think there's a manufacturing engineering program at NIU.
Mm-hmm.
And so it's a really good opportunity for the student. I was just in talks with another university here in Illinois, SIU, that if we can set up a cohort of 15 students that are interested, they will guarantee to provide the instructors at the Harper facility. So theoretically, if this goes through, a Harper student can complete the associates in advanced manufacturing and then go on and earn his or her bachelor's degree at Harper and never have to leave the area. But it would be, affiliate, the degree would be at that other school. So we're kind of excited to, be able,
Yeah.
hopefully be able to offer that. We'll see if that
would
goes through.
be a great deal for
Yeah.
somebody that wouldn't have to pay, like, stay at home. You don't have to pay for housing and meals and
Yep.
travel and all that fun stuff.
And we also have, at least for the advanced manufacturing program, we do offer a registered apprenticeship. It's registered with the DOL, Department of Labor, and they can get that information from the website too. I believe there's a separate apprentice website through Harper. But they get hired by a company. They work full time. The company, and they sign a contract. That student is given time off to attend the required classes to earn his or her associates. Instead of the typical 2-year track, it takes 3 years.
Okay.
And then they owe that company another 2 years in the contract, but they pay nothing, and they're earning the whole time that they're coming to school as well. They get paid while they're coming to school. They get paid just as they're a full-time employee.
Yeah.
And so it's such a good opportunity for a lot of these students because they come out and really at the end of that they have 5 years experience.
That's what I was just gonna say. I mean, that's a great deal. You sign up for an apprenticeship, and then you're guaranteed 5 years work experience on your resume,
And no debt.
and no debt.
And no debt.
I mean, a lot of times these days, people are going out looking for a job that's supposed to be entry level, and first thing they hear is, well, you preferred if you had some experience.
Right.
And so this kind of solves that issue. But how long has this been available through?
So I started at Harper in January of 2016, and I think they were just getting it into place then. And you know, they've changed some of the people that have managed that department, so it's kind of been pushed and then not pushed and then pushed and then not pushed. And I think we've got a person in there now that's really good, and she really pulls for our program a lot. What we really need is like a separate liaison that just interfaces, you know, with the local manufacturers, and that would help a lot. But so a lot of it's word of mouth. A lot of it, I do career fairs. I speak to local manufacturers, but yeah, it's they've you know, we did a poll. Everybody's been happy. They're happy with the students that we're turning out. Again, we're not turning out journeymen because that's just not the role anymore, at least in this area. It's different now. You know, you have to fit it into the community college structure. But and so like I like to tell the manufacturers, we're partnering with you, and I'm giving you a student that is going to be highly trainable, you know, and
On the
now-
machines they have.
Yeah, and you know, and we have, you know, the industry sized machines. We're not learning on small desktop things cutting wax. We're cutting metal, and you know, we cut 4140. We cut mild steel and aluminum, and you know, we give them a full kind of range of stuff that hopefully they'll be experiencing, and you know, I think we have a pretty good program.
That's great.
You're
That's great.
certainly very, very well equipped in the shop.
Thank you. Yeah.
Mhm. Yeah, I was pretty impressed on our last couple of visits, the new machines that had been delivered and the amount of technology. I mean, it's, you know, it's, the industry is advancing so quickly, right? The machines, the software, the cutting tools, all of that changes almost on a daily basis, right? But for you guys as an educator to be able to keep up with that, I think that's huge.
Well, I think I might have mentioned it on our previous podcast, but I'll just throw it out there again, is that, yeah, I'm super thankful, you know, especially for these new machines and the technology that we are, you know, kind of matching pace with some of the newer technology machines out there. We just got a 5-axis machine. We just got a dual spindle Y-axis lathe with live tooling,
Mhm.
and I'm really excited to, you know, start using this and be able to teach the students. And again, because we only have 2 years, and we have to learn all the fundamentals, you know, we're not going to turn them loose on this, but there are going to be those small percentage of students that are going to excel, and we have a manufacturing club where they can come in and they can and do things on their own time. And you know, I've already got students that have their eye on these new machines, and they brought me designs. It's like, I want to make this, and I'm like, I love it. Go
Yeah.
ahead, do it. And you know, I'm a big believer in that. You know, that failure is a really good teacher. And so, within reason, you know, I look over all the projects, and I'm not going to let them crash the machine. But if I see feeds and speeds that are off, like way off, and I know they're going to break a tool, I'm going to let them do it, because it's just an end mill.
Yeah.
And I want them to experience that, and I'd rather have them do that at school than, you know, get on the job and start doing dumb stuff.
Yeah.
But I think there's such a value in learning, and they can hear things, and you know, well, what happened, and then we dissect what happened, and I think it's such a good tool to show them firsthand what's going on.
Yeah.
You know, and there's some really good virtual stuff out there. I just don't think it's the same experience. And, I actually experienced at IMTS a year ago. They had a virtual machine that you could set up with the goggles and everything.
Okay.
And it looked realistic, but I was debating with the person. I said, unless you have the fear that tool could crash into the table or the vise,
Yeah.
this is never going to be the same because there's no consequences.
Yeah.
So, but yeah, I'm very thankful for the technology that we're able to offer.
Yeah. Yeah. No, I think that's amazing, and I mean, even as far as advanced programming and advanced machining, on this twin turret, twin spindle, Y-axis machine that you have, I mean, there's a lot of people who will be setting those up and making tool offsets. So even if they're not programming, it's good for them to have exposure to that, and seeing all these things move at one time is a really different experience than just watching, for instance, a 3-axis mill go or a 2-axis lathe take off.
Yeah.
Right? When you're like looking over here and something over here starts moving, that's like, oh wow,
I hope they don't meet in the middle. Yeah. But with the software that we have, with the CAM software we use SolidWorks for our modeling. I tell these students, we do a lot of tours with middle schoolers and even like early high schoolers. With the equipment that we have and the technologies that we have, it really has come to the point where if you can model it or draw it, we can make it.
Yeah.
And it really is a joy watching, like some of the students get it, and some of these kids that have never manufactured anything get it, because you can see it on their face and you can see the wheels spinning, and they're like, oh, and out of that crowd there might be one kid, but he'll say, oh, could I make this or that? I'm like, yes you can.
Yeah.
You can absolutely make that. And that's what I kind of strive for, just to plant that seed that you don't go to Walmart and buy everything. Like, they have to come from somewhere.
Yeah.
And this is how you do it.
Yeah, and Dennis and I were talking about that earlier. Everything nowadays is CNC, right? So I mean, down to the bottle that you guys are drinking from was made in a mold that was made on a CNC machine.
Yeah.
Yep. The casting that's on top was very likely cast in a mold that was made on a CNC machine. If not, the positive, if for some reason that's maybe sand cast, the positive was probably not made by a mold maker anymore. It was probably made on a CNC machine, and then they're using that to stamp it instead, but I feel like I'm starting to get off topic now, so I'll ramp us, get us back onto
Anything
the.
to do with bourbon is
But
okay.
one thing before we turn that page,
Yep.
so if anyone wants to contact me directly,
Yeah.
I can give that information out at the end if
Sure.
you want. But this
You
is
can.
this is a general number, general email, and if you going through this website, if you locate the advanced manufacturing department or even the welding department, then I believe I'm listed under there too.
Okay.
But you can also search the Harper website for my name, Aaron Kolb, and you can send me emails directly. I'm happy to answer questions. And
Is it Aaron.Kolb or just?
it's AKOLB, so akolb at harpercollege.edu.
Okay.
And again, I'm happy to answer emails, questions,
Okay.
Perfect.
Whatever it
Yeah,
may be.
No, that's
very nice of you.
Great.
Yeah.
Yeah. Thank you. So, onto some milling operations. We have here are the 3 tools that we used on the machine, and from left to right we have a 2mm end mill, 4 flutes, and a 35-degree helix. And we'll talk about this running a little bit later, but I would like to point out that the 35-degree helix is really nice when you're pocketing, because it's steep enough that it gets the material out of the way very quickly, but it's not so steep that you're slapping like with the vertical, or even like maybe like even just a 30-degree helix end mill. You hear it a lot more, and later when we run the videos you guys will hear this cut, and it sounds pretty nice. And then next in the middle there we have our 10mm 4 flute, same geometry, 35-degree helix. And then all the way on the right, the tool that we used for the spline milling, it's a 5UE insert with a 76 millimeter diameter shell mill made for a 1-inch shell mill holder. The first thing that I want to talk about is the way that we program this. So, Dennis, you talked about earlier that we were partnered with Open Mind Technology. Open Mind is the company that's created Hypermill, and we're using their CAD/CAM software now as application engineers for Vargus. So helping us provide very good tool paths for our end mills and helping us service our customers at the next level. They were nice enough to provide us most of the programming for this part, and I think we have a little video prepared next of them programming for the keyways and the wrench flats. So here, this would be, first we see the tool path, essentially, for the keyways. And I don't know if we're going to be able to play it, but we'll see the internal simulation here shortly, or possibly the machine simulation if there's a bug in that. But we can maybe just skip forward to. Go ahead.
I think he's trying to get it. Tim is the guy we're talking about in the background there. I think he's trying to locate the right video.
Yeah, I mean, we can skip forward and come back to it next. The slide 9 here shows the first features that we cut. So here's the wrench flats, right? This is a super simple feature. On this feature on slide 10, this is exactly the tool that we use. So this is what it comes up as on our website, shows all the tool geometry. It's our VM9 grade, which is a new general purpose grade suitable for steel, stainless steel cast, and heat resistant materials. And then if we go forward to 11, I think we have a video of that running on the machine. So this is actually, this is milling the pockets for the keyways, but this is great too. We're getting to that next. And yep, here we go. There's the flats. So this operation was running at 4,773 RPM, 200 inches a minute, or about 10 thou 5/10 feet per tooth. Aaron, I know you've run a lot of end mills. Any feedback for us on how this has run for you?
Yeah, at first I thought the feed was going to be, not to say too aggressive, because the depth of cut really wasn't that much, but I thought it sounded great. And there were no problems. Actually, at the end of the day, I felt like we could have probably ran it faster.
So we've run this same end mill in steel at almost 400 inches a minute with like 32,000 step over. We've run this extremely aggressively for roughing operations. And I've run the same end mill now in stainless steel. Actually, I just did it 3 days ago with about the same step over, and we were running in a sand cast stainless steel. I think we had 4,500 RPM and 192 inches a minute, so about the same feet per tooth, like 10 thou 5/10, 11 thou feet per tooth.
And even for being right in the middle of the bar. And I mean, this bar is not a big diameter. I mean, there was no chatter whatsoever. It was such a clean cut. The finish was great.
Mm-hmm. Yeah, I'm very happy with this particular product that we offer.
And can I just jump in? I mean, one of the things we're kind of showing with this whole project that we've been working on now for a little while is this is kind of a process a shop would go through to make sure that their strategy, their machining strategy, is as efficient as they can make it before they ramp up and do the full-on production.
Yeah.
So some of the things you're talking about here maybe could go faster when
Yeah.
you get ready to ramp up.
Mm-hmm.
So these are all like notes that you might be making for little tweaks in the whole process.
Yeah.
I think that's exactly right. And it's kind of like I try to tell my students, we do feeds and speeds, or even for the manufacturer's recommendations, those are recommendations. And, based on your setup, you may have to slow down. You may be able to exceed those. And that's where the experience, comes in, because, it also matters. We have tolerances to hold, and we have surface finishes to hold. So, you're exactly right as far as this being, kind of the testing ground, so to speak, of, what is going to follow for the production. But, and maybe that wasn't the case when we did the lathe, because I think we broke that up into 5 different operations where we would probably do that a lot more efficiently, but it was a really good way to show each feature of that shaft when we turned it. So,
Yeah.
We, kind of give up some to, show other things, but
Right.
Yeah, I mean, Dennis, like you said, right? This is designed, yes, to showcase the general process that we go through, right, with our customers. From they supply us a print, in this case we made the print, but most of the time we'll get a print from a customer. We'll spec tools, we'll spec speeds and feeds. They will program it. Sometimes, for whatever reason, maybe they're not able to program it, or they're not able to program it in the way that we intended to be used. And that's why our application engineers are extremely technical. Most of us can stand at the machine and troubleshoot and or write programs for their machines. And when it's a complicated program and we need help from software, we have access to Hypermill so that we can write complicated paths for end mills on, complicated geometry on 5-axis machines, right?
Yeah.
And speaking of that, I do have a little snip of the code on the next slide, and I'd like to just take a quick peek at that. I think that's slide 12.
Yes. Actually. There you
And
go.
so this is typical of a CAM generated code, right? There's a lot of lines, a lot of motions, right? If we were to write it by hand, it might be a little bit more of a straight line here and an arc there. But the thing that's difficult for us as people to really deal with is what the machine is doing, right? So a lot of times within the parameters of the machine, it's asking, hey, if you're coming in and we're looking ahead and we see a radius ahead, we're going to slow down, and then we're going to make a motion, and we're going to move a little bit and get into this corner at a little bit slowed down feed rate or whatever. And the CAM software is able to anticipate that. They know what the parameters of the machines are and how they behave, so they're able to actually help us write a program that won't have to slow down from the program's values, right? Sometimes you can still add those in. You can use the parameters of the machine and say, hey, slow down by 20% when I'm entering a corner. But if you don't want to, you can program it like this so that your your software generated cycle time will be very close to what the machine gives you. And especially when you're dealing with complicated geometry, I think that the CAM software, even if it might be a little bit difficult to read the program, really can provide a superior tool path.
no, that's true. And even when it's just entering and exiting, more so entering the work material is, these tooling engineers have figured out, the exact angle that tool should enter the workpiece for not only the best surface finish, but the best tool life.
Mm-hmm.
And so you see, maybe to us it would write things by hand, some odd tool entry because it's at a weird angle and then it arcs in, but
Mm-hmm.
that's all designed, and the CAM software is able to replicate that would be difficult for us to do, at least on the fly.
Yeah.
So
Yeah, absolutely. And the next slide, I just generated the tool path, so slide 13, and basically I just threw the code in an online simulator and got this tool path out of it. And we can see exactly what you were talking about, right? The motions for entry and exit. And you notice that the line is all one color, right? So that's all done under a feed rate, right? So we're not switching back and forth between G1 and G0. We're just moving the tool along at a calculated feed rate for the entire program. After we made these flats, obviously we had to determine if we had made them correctly. So Alacona was able to come in and measure these for us. On the next slide, we have a little image of their machine, and I'd just like to note that Alacona is located in Itasca, Illinois. That is their U.S. headquarters where all sales applications and service and support comes from. All of their machines are using focus variation. They're relying on bringing the surface in and out of focus by varying the z-axis, capturing many pictures, and then stitching them together into a 3D point cloud. The sensor featured in this content allows for measurement of dimensions, positions, shapes, roughness, all with one sensor. So they're able to measure the part completely and then take a ton of information off of the 3D model that they create. And one of the nice things that they have going on is as you can see here, they're using a colored light. That color of light allows them to get very small details that previously they weren't, and really no one was able to get, and especially on very shiny surfaces. So if you're machining to a very high surface finish requirement and have mirrored surfaces, you'll still be able to extract data using these tools. So the next slide, the first measurement that they were able to get for us was the depth of the flats. And so here basically, they had their scan already, then they just, go and highlight a couple of surfaces, and they're able to right away extract the depth of the flats for us. We're able to offset our Z value of our end mill. And then the next slide, slide 16, was the width of the flats for us, and that in this case was actually also controlled by the depth of the end mill. So both of those were able to be taken care of at the same time. The next operation that we did was the keyways. So slide 17 shows those features on the print, and so we did control this a couple of different ways, right? So we had a width that we were looking for and a depth that we were looking for, and with the 2mm end mill that we used, we were able to come in and interpolate that entire path. So slide 18 shows that tool on our website, and again, same geometry, 2mm 4-flute, 35-degree helix, pulls that material up and out real fast so we're not recutting chips. And then I think our next one is we got a video of that running. So yeah, here we go. And we ran this one with coolant just because it's a fairly small pocket. We wanted to make sure we were flushing that material out. But Aaron, again, you've run a ton of end mills. What was your experience running this one?
Again, for a small end mill, the first slot we did, we kind of entered in off the step, and I wasn't quite as concerned about it. But the other one, we ramped right into it, and it was a fairly, decent feed rate. Mm-hmm. And again, I heard nothing except just great cutting.
Yeah.
It sounded really good through the whole cutting process. And again, I think I was most impressed by, we didn't do a rough and then a finish. We just pocketed it out and it was it. And the
Yeah.
finish was really good
Yeah.
on the wall and on the bottom of the keyway. So
Yeah, I think in a couple slides we've got a visualization of that path, and we do show the code. But this we were running at 39 inches a minute and 8,100 RPM. So we had 1,210 feet per tooth here, and for a little tiny end mill,
Yeah.
I feel like that's fairly aggressive.
it is. Yeah.
And we were ramping at, I don't remember, 1 or maybe a couple degrees of ramp angle. So we were giving it to it, and it held up well as far as I'm concerned.
And Aaron, you mentioned a few times now that it sounded great. It sounded good. And what I want to ask you about is that is listening to how the machine it sounds as it's cutting. That's an important aspect of knowing how well it's
It is.
accomplishing what you want.
Yeah, and I mean, obviously that comes with time, and but it's one thing that I will do for my students, and I will take a program that I've written, and I'll run it with it way too fast, with like too high of an RPM, and I let them listen to it, and they can hear, the kind of screeching and the rubbing of the end mill, and I'm like, okay, this is what you don't want. And then we'll run it too slow, and it's almost like it chugs through it, like it's like it's gonna break.
Yeah.
And then we'll run it, kind of like the Three Bears, the just right. and I'm like, so, obviously there's some variation of that, what sounds good, but I go, this is what you're, remember what this sounds like, and
Yeah.
then remember what it sounds like when it's not good.
Yeah.
And again, it's all about trying to cut corners for them, and because no one told me that. It was
Yeah.
just, over years of experience, you're like, okay, well that I've gotten really good results with these feed and speed, so that must be what it should sound like.
Yeah.
So the reason I was bringing it up, I mean, you at the beginning you said you were a little bit concerned about going in that aggressively with this second tool, and yet everything
Yeah.
is good, and so you probably felt some relief. But isn't that, I mean, that's kind of the part of why you don't just always use the same tools forever and ever. As new things come along, there are better ways to do things and faster ways that are with tools that are more capable. I mean, I'm not
Yes.
trying to do a sales pitch, but that's the bottom line here. Things continually improve,
Oh, and I have
and so things change.
And I have 1,000 stories about that for another time, but it's so true that, and I think it's really easy for people to just say, well, this is the way we've done it.
Right.
I'm just going to do it this way. And yet, whether it's a tooling manufacturer like Vargus or someone else, and they come in and they say, well, but we've got something that can do it better.
Yeah.
And a lot of these, old timers, it's like, well, you need to show me. And then where you come in and you set it up, and it's like, oh my goodness, you cut my cycle time in half, and it looks fantastic.
Well, so let me ask you about this, right? There's the feature we're machining.
Yep.
The slot width is 118 thousandths, and we are.
What slide are you looking at right now?
I'm looking at 17. So we're 874, and so we're like 50 thousandths deep and 118 thousandths wide.
Mm-hmm.
If you saw that feature on a print 15 years ago, what diameter end mill would you buy?
Oh, good question.
Well, with a 118, I would, and again, I know that's 3 millimeters, but I would, if we're talking about imperial, I would probably get a 3/32, which is 0.93,
Mm-hmm.
and I'd go in there and I'd rough it out,
Mhm.
and then I'd probably go in and I'd do a tool path around it to finish the slot,
Mhm.
instead of getting something that I think we had the end mill that was right to size, and we went in and just I think it ramped down and then just went back and forth and finished the slot.
We had a 2 millimeter wide end mill, so we had a millimeter of clearance, and we were basically helixing down the entire time. But so with what you said, I'm sorry, 330 seconds mill that you would
Yeah.
have used to basically go down and then rough all, you would like go down almost to depth and then rough a slot through,
Yes.
and what feed rate approximately?
You know, and I don't know what it would come up with as far as feed per tooth, but you know, because we've, you know, a company I used to work for, we did similar parts, and I can think of feed rates that were probably in the 10 to 15 inches per minute, and I
Yeah.
think we were at 30 or 40, 35 maybe.
We had program 39, so
Okay,
we
yeah.
were, you know, 3 to 4 times faster than the standard feed rate maybe 10 or 15
Yeah.
years ago.
Yeah.
Right? And I mean, you saw the video, right? Our entire cycle time was, I don't know, maybe 15 seconds per pocket or even less, maybe. And
Mhm.
here he's playing it again. So,
Yeah, that it hardly made any noise.
I think a lot of these tools can be run dry too in steel and certain materials.
yeah, absolutely. I mean, if honestly, if it wasn't the first time we were running it, we probably would have just run it dry. But we're like, I don't know, it's 2mm ML. Let's run it with
Mhm.
coolant.
No, that's
Um,
cool.
And just while we're looking at this video, Aaron, tell us a little bit about this machine and this setup.
Okay, so this is a Haas VF2, which is now you're going to get me here. I think the table is 16 on the Y, and I think the travel on the X is 24, maybe 30.
How new is it?
This machine's a couple of years old. This is well, prior to our just delivery of the new machines. This was our newest mill, and so we have a 4th-axis rotary on there, and then a tailstock to support the part of the left end. And we're just doing the keyway, and then we're able to rotate over to the next feature. But it's yeah, solid. You know, pretty solid machine.
Mhm.
And again, it's very new. It's very low hours, so everything's nice and tight on it. But
Yeah.
you know, so that helps too.
Yeah.
It's not a 20-year-old machine, but which we have one of those too that works, you know, pretty well.
Yeah.
But
Yeah,
Yeah, it's not a 20-year-old machine that's seen 3,000 hours a year of production, right?
or more, yeah.
Or more, yeah. So, again, we do have a picture of the code on slide 20, and then on slide 21, we have the tool path. And again, this is typical of code that would be generated from a
Right.
CAM software, right? So, again, you're seeing a lot of movements, but the thing to keep in mind here, if we go to slide 21, the next slide, so here's a couple different views. We've got a top view, a side view, and an isometric view, or a 2-point perspective view. So on the top picture there, you know, you can see kind of the path that we went around with the end mill. On the bottom right picture there, we have a picture that shows clearly that we're moving down at an angle, and then that picture in the kind of the middle on the left is showing, you know, that we arced in to that path, and then we followed that path around and down all the way to the bottom, and then we had one pass at a level plane to keep clean up the bottom. I mean, realistically, that's cleaning up the bottom and the sides, but we didn't move over. There was no like 5,000ths offset to, you know, clean up the sides of that. It was just all done in basically the one pass. And like you
Well-
said, Aaron, yeah.
I was going to say, I don't want to interrupt your train of thought, but get a note from Tim that if you wanted to talk about that programming video that was part of the slideshow, that is ready to go whenever you, if you want to go back to it.
Yeah, great.
once we get
Let's
through here.
let's jump back there. We'll
Okay.
jump back there, and then we'll get into the measurements of this feature. So
What slide was it again?
that would have been. Let me look back through here.
No, I think he's.
Oh,
getting
here we
it.
go.
There we go.
There it
So
is.
here's the machine simulation, right? And you're seeing that keyway slot get cut right now.
Yeah.
So we're moving around the profile of that feature, and we're moving down at the same time. And then there's the 4 passes for those wrench flats or indexing flats, whatever you want to call them, and it's done, right? So here again, you can see arcing in and moving
Ramping,
down at a
Yep.
exactly at an angle.
And this part isn't in, as far as like students may be concerned, this would be an exciting part of the assignment, if we can call it
It would
that.
be, yeah, and it would. What's nice about a part like this is it's not, at least the milling portion of it, it's not extremely difficult, but it's got different features on it that would require, like, if a student was doing this, to have to think through, because each feature, whether it's the keyways or the wrench flats, they have to be in a certain location, and it's. And again, and that's just, it's another concept that they have to learn. It's more than just the programming. It's like that feature needs to end up in a precise location on the part. And and we talk about things like that. And then we talk about the order of operations, because and for this part it probably didn't really matter, but for some parts it does matter in in the way you do things. You might not want to mill things before you drill the holes, or or vice versa. It really is part dependent.
Yeah.
I've got another question. Does the simulation ever show, like, no way, this approach isn't going to work? Does it show
Yes.
like
The
or
short
an
answer
X?
is yes.
Yeah.
Okay.
Um,
What would that look like? What would you?
So the simulation now is really good, and I'm not intimately familiar with Hypermill, but I know Hypermill is one of the top tier CAM programs, and I know, so I'm assuming them and some of the other ones, the simulation has gotten so good now that it's very reliable to say, okay, well, this is going to hit this part, and you can set clearances within that CAM program to say, okay, I want the program to stop if it comes any closer than 50 thousandths to a tool fixture or whatever it may be.
Yeah.
And so you have control over that. But you can see if that tool path is wrong and it blows out the side because something, you chose a wrong feature.
You accidentally put in the wrong number.
You'll see that.
Yeah.
The one thing I will say is, and again, I don't know about Hypermill, but I know most, if not all, CAM programs, they simulate off of the features and the entity of the solid model. They don't simulate off the G code, and there is a difference. And so there are other companies, and again, I'm not pulling for any particular company, it's just the one that comes to mind, is Vericut. And what they've done is it looks very much like this, but they will come in and they will set your machine up, and they will take all the telemetrics of your machine, and they take test cuts. So it's your machine. When you see your machine on the screen, it's literally a digital twin of your machine in the shop. And they basically guarantee, because what they're simulating is the G code. And so the G code that the CAM program spits out, that is exactly what they're simulating. And they basically guarantee that they said if it does not crash on the software, it will not crash when you run the machine. But again, that's for probably the customer that wants to be absolutely 100% sure that nothing is going to happen. But for everything we do at school, at least now, we simulate everything through the CAM software, and it's extremely accurate.
Yeah, and Hypermill, just like the rest of them, right? I mean, you have an entire database, right? So you have a database of tooling, a database of tool holding, a database of work holding, and basically you just bring it in, right? You say, okay, here's my part, here's the stock model, here's the finished part, here's my vise, here's my jaws, whatever dogs I'm using, jacks I'm using, whatever you have in your setup should be represented on the solid model. And then basically you can say, yeah, turn on collision checking, and then if you're going to run any part of that setup into any other part of that setup, or basically any non-cutting feature of that tool, or anything that's non-cutting into anything that's not supposed to be cut, it'll put up a big red ball and say, hey, stop, we got to change something,
Right.
you know?
Don't try this on the shop floor. Okay.
So it's good graphically, right? And it also, in a lot of cases, won't let you post code because, like you said, Aaron, you can say don't come any closer than whatever safety number to these features, and it will know to avoid them, right? And that's to me very important. Why also we not only have our machine represented properly, but we have our stock represented properly, right?
totally.
Because
Yeah.
if we're starting with, let's just say, a casting, and we've got, a fairly approximate hole that we're supposed to be entering, well, we don't want to start sending that tool down, over somewhere where that hole is not, right? Or if we're starting with, maybe a blank, and then we drill a hole and we're sending a thread mill down into that hole, for instance, we don't want to try to send that thread mill down into solid material if it's not a TMDR, right? Like
Right.
we want that thread mill to go into where it's going to cut, and we are able to check that through the software and know, for the most part, prior to going to the machine, that everything is correct, right? I think we have a couple slides, slide 22, of some of the measurements for this keyway. So I think it's the next slide. Yep. So here we go. We have here, I don't know if this is a video or not, but if it is, Tim, can you try and press play and see if this will play for us? Because we have a nice animation of Elizabeth getting some of the information cleared out. Yep, so getting some of the extra information cleared out, selecting the feature that we want to measure, and then generating actually the measurement values very quickly, just a couple of clicks, right? And Aaron, I don't know how many keyways you've had to measure, but I've seen a lot of people try to measure it with like the backside of their calipers,
Yeah.
and it's like, are you sure you're measuring that perpendicular to the axes you're supposed to?
Yeah.
Or like, do you really have the correct stack of gauge blocks to get in there and measure the go and no-go limits of that? So that, like, a feature like this is just huge. The measurement is very
What-
quick, very precise.
Indicate to me what any number on the screen that people are looking at there that is showing them proving to you that it cut it well. And
So
this-
that 299.24, or I think it was that came out 299.24, that's millimeters. So 2 millimeters, 992 microns. That's very close within the allowable tolerances that we had for this feature to what that was supposed to be. And if we needed to, we could have easily offset that feature by 4 microns, but that's realistically in this feature. I think we had a tolerance of a plus or minus a thou, or plus or minus 2 thou even, and we don't need to worry about a couple microns. So that's a very nice way to very quickly verify that without a lot of struggle and setup, right?
And this was what Alicona, this
This-
was the part that we did.
Yep.
Alicona ran through their
Yep,
little,
exactly. Yep, and then the next feature, the next slide, 23, is we have them measuring the length of the slot, making sure that our keyway stock, our key stock, will fit into that slot appropriately. And again, that measurement was made from the same image that they took, right? So there's no need to change fixtures, change measurement tools. We're not holding it our hand, heating it up if it is like a very tight tolerance thing, right? They're holding it on a rotary stage on a machine, and they're able to generate extremely precise measurements with that. the next feature that we had on slide 24 was our SAE-B spline. This is SAE-6B, so there's 6 lobes to it. And you can see that this is controlled by, very simply, right, the distance between flats and then the diameter that those surfaces are at, right? It's very much not a complicated spline to measure, but it still presents some challenges, right, for machining and for metrology. So,
Did you mean measure or cutting or both?
well, it's not necessarily complicated to measure based on the way it's dimensioned. There's always, inherent difficulties in obtaining accurate measurements, right? Maybe, the anvil on your micrometer is a little too wide to fit in there, or whatever, maybe, it's hard to get exactly onto the plane that you're trying to measure at. Things like that always crop up. It is a standard spline, but it's actually a very difficult spline to cut because of its size and the volume of material that's being removed and the shape of it. Even with a fairly small depth of cut or feed per tooth, you're still removing a lot of material. And so you need a very robust tooling system to be able to do this effectively over a production run, right? And so that's what we've tried to showcase here. The next slide, we show the insert and holder system. So we had a U style, which is a nice beefy insert, and it's rotated so that the geometry is basically on center and we can get the width out of it that we need. And then we're using a shell mill to hold this, and you can see that the insert is fully supported on the back side, and then it's crammed down into a pocket and captive on 3 sides. Well, I guess 4 if you count the back, right? So it's a very rigid system. It's designed to be used on a shell mill holder, which shell mills are known for their robustness. If you've ever used a big face mill or things like that, they're always on big shell mill holders, right? Because they're designed to do a lot of material removal. So that's the system that we're using for this type of operation.
One thing I'd like to just say about that holder is I'm not super familiar with cutting splines. I've done it a handful of times. I really like this holder in that not only was it robust, like you said, but it had some mass to it, and I felt like I think the way the holder was constructed was one of the reasons that it cut so well, because I think the mass, it absorbed so much of if there was any vibration or anything, and of course that's going to create more inertia as it goes through the part. So I think that combination of the insert and that in the shell mill holder, were really effective.
Yeah. Thanks for saying that. I think we've got a video of it running here.
Next slide.
It's on slide 26. Yeah, here it is. So for this operation, we started pretty conservatively. We started at 382 RPM and 3 thou feet per tooth. We were conventional milling. We could have turned this around and run it the other direction and made it climb milling, but then we would have had to arc into the part, and we ended up handwriting this program. I'll go over that next. Aaron, you talked a couple times about having a little bit of that fear and that being healthy for not wrecking machines and wrecking tools and things like that. Do you remember when you pressed start on this operation? Yeah.
Yeah. I mean, what's there, and I think it's healthy for that to never go away.
Yeah.
But there's features on every machine, not just the Haas machine, that you can look at the program, and then you can look at, there's a feature on there, distance to go, and so you can figure out where the tool is, and then you look at the program where it's going to go, and then you look at the distance to go, and it's like, okay, it's got this much to get there. So, and if it seems reasonable, then you just let it go. And but you know, when it rapids into that part, it's still, there is a little bit of a fear factor that I hope it works.
Yeah.
But no, it was all good, and it sounded like, again, going back to the, you know, the sense of hearing, it sounded really good going through the part.
Well, to use it properly, you have to trust that it's gonna
Yeah.
do what it's purported to do, right?
Yeah. Well, I mean, there was, I guess, to me, a couple of issues, right? One was I was having some problems with my computer. I couldn't get Hypermill running when we programmed this, so I had to program this by hand.
Yep.
I programmed a macro for this because we had talked about you maybe cutting some other splines, and we wanted to give you something that was scalable.
Correct.
Right? So, you know, now you have a program that basically you change a couple of these variables and you can use it to cut just about any spline that you want to. However, when you look at the program, all you see is X is going to this variable and that variable. You don't see where X is going to, right?
Right.
So when you look at your distance to go, you're like, is it actually 510? What does 510 equal?
And if we wouldn't have had the printout
Yeah.
of what those variables were,
Yeah.
yeah, it would have been a little more fearful. So yeah.
So this is the program that we used, right? And
And it could have been done with the Hypermill, but
Absolutely.
for whatever the issue was.
Yep, absolutely could have been done with Hypermill. There was some technical difficulty on my computer, and we weren't able to get that working. But you know, this, like I said, I mean, there's definitely a time and place to use CAM software, and in some cases, you're better off to write a program like this, right? And like we talked about, you know, there's variables in here for the size of the part, the depth of cut of the spline, the diameter of the tool, the length of the cut, the number of lobes. So realistically, by changing 5 variables, you can cut just about any spline that you want, right? And it doesn't matter if it has, you know, 6 teeth or 60 teeth. It doesn't matter if it's on 087 or a 4-inch diameter. Like, just by changing those variables, this program will cut all of those splines for you, or mill however many flats or whatever you want, right? So obviously we have this program here, and then on the next slide I made a little simulation of that, but in order to get it to simulate, I had to break the code out and show you how long it would be if we wrote every feature. And then, you know, just imagine if we needed to make some offsets and we needed to change our X values or something like that for our length of cut on all of these lines. The opportunity to miss something becomes huge, right? Rather than just changing one variable and everything changes, right? So in some cases, you know, it's, you know, almost just as fast, and in some cases it's more useful to have a small macro like that written.
Well, especially for part families,
Yeah.
you know, similar parts where they might just change in size, or in this case, number of splines, because you've got one program that kind of does it all by just changing a few variables, and you're once you've written it, you know, now it's done and it's set for any number of things that you want to do with it. So yeah. It's
Would that work? Can you put that in and have it simulate if you wanted to?
You would need a really advanced simulation engine. So when you deal with macros that have variables, there's not a lot of simulators that'll read the variables. And then we also have a loop in there, so we're counting, so they would need to index the variable every time that it went through and count it one higher. The machine will do that. But no, you talked about Verica. I don't know if Verica would do that.
They do.
Okay.
Yeah.
Well, there you go.
Yeah.
So, you know, there are some simulators out there that have the ability to read that code. The, you know, cheap online simulator that I was using did not. So I just, you know, I had to expand the code to show you what it would look like if it was all written out, and then to show you what the tool path would be.
Some of those online simulators, they will do it in the paid version.
Okay.
And it will list it. It will say,
Do tell.
And I'm trying to think of what it says, but because some of the ones I've looked at, it'll say, we'll read macros, in this version.
Yeah.
But the free online version won't.
Okay.
So, I think it's, I think it's just something that if that's something that you need, you just have to look and make sure that the
And you might
program is going
have
to do it.
pay a few dollars for
Yeah,
it.
it's not outrageous.
Yeah.
So,
Right.
Yeah, and I think
For anyone learning, I mean, this is good information that you could plug this into something online and get one of those simulations of something you've written yourself.
Yeah, I mean, especially for somebody starting out, I mean, there's so much to learn. Any software that you can use to help you verify things that you've done, to give you a little bit more assurance that things are okay, especially, I mean, I remember the very first time I ever pressed start on a CNC, and I already had a couple of years of manual machining experience, but just not having 100% faith in the program and my abilities as a programmer, and I'm just like, imagine you're a valet parking guy, right? And somebody just drives up in a Ferrari and gives you the key. Like, part of you is going to be excited to drive it, and part of you is going to be scared to go around the first corner. What happens if you hit that curb and dent the guy's fender or scratch his wheel, right? Like, that's kind of the same. Meaning
you
fear.
don't want to hit the curb.
You don't want to hit the curb.
Well, okay, good.
Yeah,
Just want to clarify.
yeah, absolutely. And I think most normal people would feel the same way, right? I mean, it's like, I'm basically being entrusted with, something, the value of a very expensive car, and, I have the keys and I'm about to turn on the ignition, and, when I press that start button, we're going around that first corner whether I like it or not, because I'm not entirely sure I'm going to make it to the break in time if something goes wrong, So yeah, these software tools, I think, are really powerful, really helpful. So here's...
What is this?
This is another simulation of the tool path. This one is in Hypermill, so this is not a machine simulation, so there's not necessarily collision checking here. You don't see the stock being removed, but you still see the tool path, and it's a very effective tool for making sure that you have the correct motions that you're looking for. So, here, this is a video of Josh from Hypermill doing the programming, but basically you saw him bring up the tool, turn on the tool path, and start the in-software simulation, and you're watching it go through the tool path and the cutting motions there. And, just like we were talking about, being able to make sure that, it's not going to wrap it through the part when it goes to the other side, that it's actually going to go around the part, is like, that's huge, because, I mean, realistically, when you're programming that, G1 to G3, they're close, 1 and 3 are close to each other on the keyboard, right?
It's pretty easy to type in the wrong number.
Yeah.
I liked your car analogy for the CNC, and it was a few years ago I had a student that used the car analogy, and he was a returning, not a returning student. He was a student that came back to upskill, and he had worked in industry for a number of years, but all running manual machines, and his employer was sending him back to do CNC. And we were in the lab the first time, and he was very nervous to, like you said, run that first part on it was a CNC mill. Okay. And he was the one that brought it up, and he goes, "This is like I just read in the textbook of how to drive a stick shift car, but I've never done it before." He goes, "I've milled a lot of parts, but," he goes, "we read about this in class, but I've never done this before. And so he goes, theoretically, I know what to do, but he goes, I'm scared blankless right now. And he goes, and I'm like, you're good.
Doesn't that go back to feel? I mean, I drove a stick. I love
Yeah.
a stick. I mean, best gas mileage ever. But yeah, I don't know if they even make sticks anymore. But the feel, you've got to get the feel for that.
Yeah. Or
And
it's
until
clunky.
then, you're grinding those gears.
Yes.
Yeah.
But that is a great analogy.
Yeah.
Yeah.
I
Yeah.
wish I could claim it, but it wasn't mine.
That was good.
Yeah. So Alacona was also able to measure this part for us, right? And we saw previously that
Oh yeah.
that was controlled by a couple of diameters. So I think if we play this video, obviously they scanned this, they drew a line across the feature that they wanted to inspect, and then they were able to snap some circles into those features, and then tell us basically what the diameters were at, right? So again, if we were trying to measure this manually with a mic, it's doable, but do we have the right size anvils for our mic? And can we get things lined up, and can we get it out of our hand quick enough to avoid transferring heat into it and all that fun stuff? So their ability to measure it quickly and accurately is a big help to us in setting up and making sure that everything was great. So I think
That's all non-contact. What the technology they call it again?
the focus variation
focus
technology. So they're not touching the part whatsoever. There's not even a probe stylus, right? Because and I mean, I come from the cutting tool industry, right? I've worked in this industry for a long time, and like, let's say you want to measure the edge of a cutting tool, even if you touch it, with just a few grams of pressure with, something that's designed to touch things very lightly, like some of these probing tools that are out there for CMMs, it might be enough pressure to break that cutting edge. And obviously you don't want to do that. You don't want to have a nick in your cutting edge, or a mark on your part if you've worked very hard to establish a very good surface finish. You don't want to be scratching it with contact metrology. So the non-contact metrology is very much appreciated, and very accurate. So again, thanks to them for giving us access to this equipment to measure these parts. And I think that pretty well sums up the milling operations that we went over. But I do want to say a big thank you to Aaron for letting us use your shop and your machines, and thank you for your time.
I was very happy to do it, and I'm happy to do other projects that you're interested in working on. I've done this for a long time, and I love doing it. So,
Right.
Yeah.
Speaking of which, I mean, this at this stage, somebody would be done now, and they'd be ready to take the tools that they've secured from Vargus and figured out how to use them properly, and they're ready for production.
Yeah, so I mean, if we were doing this, for instance, as a test cut, which was a service that we provide for all of our customers and prospective customers, is that we can get tools out to customers on guaranteed orders, right? So that if they would like to test something before they fully commit to it, they're able to. We will help with either giving recommended cutting conditions, or help by supplying programs if necessary for them to be able to run their features using our cutting tools. We come out, we stand at the machine with them, make sure that everything sounds good, looks good, measures good, and then after we've run the first part, they put it into production. Maybe we'll stick around for a couple of hours to make sure that there's no kinks, right? And after that, we leave. They have a working process that maybe they didn't have before, or maybe we've been able to provide some type of process optimization, whether it be better tool life or better cycle times, or both. And so it's really a win for everybody, right? They get hopefully a better, more robust process out of it, better, more robust cutting tools, programming that's designed to work in the way that they want to and fits their needs. And, they're basically getting the value of a consultant just by buying a couple of cutting tools.
And I would expect that kind of service from anybody, and you're providing it. And I think that's one of the reasons that drew me to want to do this, so that we could show everyone out there, it's not a small amount of value to have this expertise come in and show you exactly what you're going to get out of a tool that you've purchased from them.
Yeah.
And the best way to use it, because it's not always obvious. And I only know that from the short time I've been involved in this industry, since 2007. But it's different when you're covering it as an editor. You don't have the experience of hearing and the feel for something that goes wrong, or just that doesn't make any sense, and you just can't believe some tool's going to go that fast. You actually have to see it and hear it to believe it.
Yeah.
And another thing, I just want to add this. This was so much fun to watch you guys working on this and work through whatever issues that came up along the way and work through them. It's been really great to experience that, because I actually got to feel like I learned a little bit more by being part of it on the floor.
Absolutely. I mean, and I have fun doing it. And to one of your points that you just mentioned, unfortunately, not every tooling company provides that service, even though you would think that, if you're buying someone's tools, that they would have maybe a more personalized service. But it's, it's not always like that. Or, it might be just some recommendations out of a book and you're kind of on your own. And, I hadn't worked with Will here before last spring, and even the little bit of stuff that we did last spring, I mean, you can just see how involved they are, and which I appreciate, and again, that's something else that that I try to impress upon students. It's like, these tooling companies, the good ones, spend an incredible amount of money every year in their R&D department, ensuring that these tools are going to, perform at, the feeds and speeds that, far exceed what you think they're going to do, and it, at the top of the limits. And so you need to rely on them whenever you have a new job, whenever you're trying to improve maybe an existing job. And, don't be afraid to maybe pay a little bit more, for this tool than some generic tool that you're using, because you're going to get not only a premium tool, but you're also going to get the knowledge that comes from the design of that tool and the people that that have designed it and that use it, and just a little bit of threading that we did last spring. And again, I've done a fair amount of threading on a lathe, and William came in and said, "Well, no, I think you need to run it this," and it was, I think my reaction was, "Really?" And just blown away by how well the tool worked. And again, those are kind of the advancements in tooling that you were talking about.
Exactly.
And it's like, wow, I haven't done this in a while, but this is certainly
Seeing is believing.
such an improvement from the last time that I had threaded apart.
Yeah.
And so I do think there's an incredible value, from kind of leaning on the tooling manufacturers such as Vargus for their knowledge of what that tool can do and how it should be able to perform.
Yeah. Yeah, no, I appreciate that, and I think that we are maybe not entirely unique. There are plenty of, very good tooling reps out there and application engineers that work directly for companies, but a lot of my customers tell me, like you said, that, well, such and such guy would have dropped off a tool and pointed us to the section in the catalog where
Yes.
it has the speeds and feeds. And, you know, although that is helpful information, you know, an example in our catalog is that, you know, we say for, let's say for 4130, that you can run between 200 and 540 SFM. Well, at this particular application, I mean, that's a wide range of surface feet per minute. How fast should I run it, right? Which tool path best suits the higher SFM? Which feed per tooth best suits the higher SFM?
Yeah.
Because, you know, whatever. And, you know, the thing, like for me, a test cut, a regular test cut is like at least a 3-day long process, right? So there's the day when I prep for the test cut and order the tools and maybe go over programming and get everything ready ahead of time. And then we go out to the customer and we implement it. And then we follow up to make sure that it worked, or if we need to make process changes, you know, speeds and feeds or programming strategy, and then do it again. Now that test cut is longer, but it behooves me for my customers to be successful, because if they are, then they're buying more cutting tools, right? And let's, you know, face it, everybody's driven by their sales numbers, and, you know, if it doesn't work for somebody the way they want it to, then they're going to try something else and probably make the same mistakes with the next tool that they made with ours, but they'll just keep trying something else until their mistakes work with that cutting tool rather than fix the process, right? And I don't really want them just to buy our cutting tools. I want them to have a reason to buy our cutting tools. So a lot of times, if it's applicable, we'll also do cost saving studies with the test cut, right? So when we follow up to make sure that everything worked, we'll say, okay, now, great, it worked. How many hours did it save you of machine time? How much dollars did it save you in revenue, or in, you know, overhead costs? And we'll take the time to show that to the customers, because, I mean, a lot of the manufacturing engineers out there, they get paid based on cost savings too, right? So if we're helping them show that, they can show that to their boss, and that's another reason for them to bring us back for future projects. Because, I mean, I've got some customers, you know, where we can easily save 1,000 hours worth of machine time a year just by changing tools and programming strategy, right?
Yep.
It doesn't always work out to be 1,000 hours, but, you know, one customer recently, we saved them $300,000 in machine time by changing one thread mill, tool, and program. One operation, one thread per year, $300,000 worth of cost savings. Right? So, I mean, that's what we want. We want everybody to be successful, because when the end user is successful, they're able to make more money, they're able to justify the higher quality tools, and, you know, we're able to continue to provide this level of service to everybody.
Will, what would Joe Vargus say about that savings?
I think
I mean,
he'd
Joe
give us a
McGee.
fist bump
Joe
right now.
McGee. Yeah.
Well, and you know, and I do think it's really important, because, and again, the other thing I try to impress upon, like, my students is the savings that can be done, not just in tooling, but, you know, in the way you program and in the way you set up and all this. But where I do think it's so important is it not only can put more money in say the manufacturer's pocket, but it also makes us more competitive with the parts that are being made overseas. And, you know, it shows that we can be competitive, you know, in a lot of cases, just as competitive as, you know, something being manufactured, you know, out of this country, that, you know, they're relying on the low labor cost. But when we're able to be twice as productive, you know, now all of a sudden we can bid that job and we can be competitive.
Yeah.
So
That's exactly what Joe would have said. As a matter of
Yeah,
fact,
no,
Joe
it's-
McGee is the senior application guy.
Yep.
He's been around for a lot of these episodes, but it's almost like you're channeling him right now.
No, it's very important. There's actually, I believe, the gentleman's based out of Buffalo Grove, which is it's another suburb very close to where we're at here. And he's a former CEO of a machine tool company, but he heads up this nonprofit called the Reshoring Initiative, and he talks about things.
Are you talking
like
about
that.
Harry Moser?
I am. Yeah.
Well, he's not in Buffalo Grove anymore.
Oh, okay.
But he's in Florida, but he still does that. And,
Okay, yeah.
And he's very, very actively involved. Yeah.
But that's some of the things that he talks about is looking for ways to be more competitive and, reducing cycle times and, improving, by using cutting tools or maybe using automation in some cases, or, there's a whole host of techniques. But again, it's being competitive and showing that we can make high quality parts here and still be competitive, with other manufacturers around the world.
Mm-hmm.
And that kind of brings me back to your role as an instructor for advanced manufacturing. Whether it's learning how to use manual machines, which you have at your shop, and you do teach that.
Yep.
But also the CNC machines you have, getting the workforce ready for that next step this country needs to take is crucial. And your program, it's one of the reasons why we wanted to work with you, is kind of shine a light on the courses that are available.
Oh, and I appreciate that.
And the training that people can get, and just to shine a light on what it's like to have a career in machining. I mean, I think we've helped show some of that here. So,
well,
and
and
it's
again,
been fun.
in addition to just the skills, and it's something that, like we were just talking about, one of the things that I try to bring to my students is it's also the mindset of being productive and high quality, and it's more than just learning these rotes or these basic skills, but it's having that thought process of how can I be better, and like I try to kind of hit into my students' heads is it in some ways, unfortunately, it doesn't take a whole lot to be better than your coworker, in that there's a lot of people that just want to do the bare minimum, and I'm like, don't do the bare minimum, look for ways to be better. And that's kind of I say that a lot. And
why? There's a good answer to that. Why should someone constantly look for ways to be better?
Well, and there's maybe a selfish reason, and I do talk about this, and the selfish reason is that, one, it's going to get you noticed, and these days it doesn't. And I tell them it's not that hard to stand out, and you're looking at ways to improve, and you're running that machine, you're setting up that machine, you're programming that machine, and there's, in every shop I've ever worked in, there's always been this high wall between the people on the shop floor and the people in the office. And in every shop that I've run, I try to kind of break that barrier down, because like I told the engineers that used to work for me, I'm like, that person running that machine for 8 or 10 hours a day knows more about that machine than you will ever know.
Mm-hmm.
And they know things that you don't, and they know how to make things better. And I said, if you tap into that knowledge, just because they don't have that 4-year degree doesn't mean that they're not intimately familiar with that machine and are very knowledgeable about that.
Yeah.
And yet I have to talk to the shop floor people, in that my guys in the office know things that you don't know, and you need to feed off that as well. And it's like a well-oiled machine when you can get all these parties working together, and you can be a very competitive organization, and you're not just competing against people here, you are competing against people overseas.
Yeah.
And you can do that.
Right.
Well,
and proving that bottom line, that ROI.
Yeah.
I mean, that's what you're after all the time.
And a quality product.
Yeah.
It's
And realistically, like, the selfish reason to me is dollars, right?
yeah.
So, basically, let's say somebody achieves a certificate or even an associate's degree through Harper and goes into a shop as maybe a setup guy or an operator, and they're making a wage, maybe around here it might be, what, 18 to $22 an hour,
Start.
maybe.
Yeah.
And then if they do a good job, if they excel, if they show initiative, what's the next step for somebody like that, right? Like, how quickly might somebody expect, and I know there's maybe not a typical situation, but, within a couple of years, somebody could pretty easily go from making 40 grand to making 60 or even $90,000 a year.
Yes.
In a machine shop.
Yeah.
Aaron, it's good to hear you say that, Will, but Aaron, you're probably very familiar with people that that you've been through your
So
program.
the one thing that I've always loved about manufacturing is that it's not like your wage is not dependent on you just being there a certain number of years. And if you come into a place and you've got 3 years experience, yet you can do the same thing as that person that's been there 10 years, you've got a pretty good case of saying, I want to be paid what that person is being paid.
Mm-hmm.
And a lot of these people will pay you that because they want that talent. And
Because it's in short supply. For
it is
one thing.
it is in short supply. And I just one example, and I had this young lady in my program, and she was working, and she had worked at this place, I think it was a year, and I think she was somewhere around $18 an hour, and she was a very bright student. And when she graduated the program, she came to me and said, can you help me find another job? And I gave her 3 places to apply locally. And I said, I don't want to give you one place because I want you to pick it. And so she settled on one, and she was thrilled because they offered her $22 an hour to start. And so right away she's making $4 an hour more than she was making. And I think it was about 6 months later, it was definitely less than a year, she called me at school completely excited, and she was like, you're never going to believe what they're doing. She goes, I had to move to second shift, but they put me in charge of a cell. I'm going to be setting up that cell, and she says they're boosting me to $27 an hour. So in less than a year, she went from $18 an hour to $27 an hour.
Mm-hmm.
And I recently spoke to her, and now they're actually gonna send her to school, not with us. They're gonna send her to the manufacturer of the CAM software, and they're gonna make her a programmer. And I go, what are they gonna pay you? And she doesn't know, but I'm sure it's gonna be another bump, probably into the low $30 an hour. So, it's again, and that doesn't happen for everybody.
Yeah.
But I feel like most people have that potential if they apply themselves, and she definitely applied herself.
Especially these days, the potential is there.
Yeah.
Yeah.
There's the supply is so lacking right now. There are plenty of opportunities right now
There's a lot of opportunity. Yeah,
Yeah.
there
in
is.
this industry.
There are, and they're career opportunities, right? It's not
Seriously.
a job where you can go and get a paycheck, and some people treat it like that, but you
It's
can
creative.
build a future for yourself and your family
Mhm.
working in CNC in manufacturing, and you can climb the ladder. I mean, you've been in manufacturing for a long time, right? I've been in the trades for 22 years. I've been in CNC manufacturing for 16 years now, right? I mean, I still have all 10 fingers. You still have all 10 fingers, right? Like, I mean, it's not necessarily a dangerous, dirty job,
Yeah.
right? I mean, there's plenty of facilities that I go into on a regular basis where you could literally eat lunch off their floor.
Yeah.
I mean, there are those places that don't keep up with their cleaning and their maintenance, but realistically, those places are very likely going to go out of business, right?
And they're in the minority at this point.
They
I
are,
believe,
for
yeah.
sure.
'Cause those are the ones that also aren't keeping track of their costs
Yeah.
and their cycle times and everything else.
Yeah.
Yeah, it isn't the industry that my parents thought it was, and my parents were the World War II age.
Yeah.
Mhm.
I'm young, the youngest of 10, so it goes way back for that.
Yeah. Well, I mean, I think that way of looking at manufacturing goes back realistically, like all the way to like the matchstick kids, right? When manufacturing was unsafe, when it was unhealthy, right?
Yeah.
And it really revolved a lot on human risk and human labor, right? And nowadays, I mean, you know, especially in places that employ robotics, realistically, you're very far removed from any type of danger. You know, it's a very safe job.
From the moment I saw machines working, when I started working in 2007, and I went out to a shop to do video, and I think I mentioned this before, but I saw what they did. I think it was called ProTurn, just north of here, but it was just amazing to watch the chef just cut these pieces and then see these shiny, you know, metal pieces come out of the machine that it was just like attacking that metal like it was a knife cutting butter, and then you see this shiny thing coming out, and just looking at it, and just from that point on, I just thought, this is not what I thought this industry was going to be when I first took this job. It's been that interesting to me ever since, and you know, just capturing this and alerting anyone in this in hearing this podcast, if you're interested in manufacturing and machining in particular, this is a career. And you know, as a testament to the two gentlemen sitting here, it is incredible to me that we can have such a scarcity of the workforce to fill all the jobs that are currently available. That's one of the reasons I want to get more involved with Harper and the other community colleges around and throughout the country, and that's why I work with Terry Iverson and SME and AMT. They all have their hands in trying to get the word out about manufacturing careers. This is a profession like any other profession.
Mm-hmm.
You are trying to make the production better all the time. Yeah, you know, if anyone knows someone who's looking for something, interested in looking for a job or a purpose, this is a good place to start in your search, because for one, it's not going to take a huge investment on your part to get a degree in anything, is it?
Mm-hmm.
Yeah.
No, you're going to go in, you're going to say you're willing to, you know, play with computers. I mean, and do some maybe programming and or simulation, and once you get involved in and did I forget to mention that these are full-time jobs, benefits, and honest to God, I mean, there's so much creativity involved in trying to make everything more efficient.
Yeah. Well, and there's
a lot of satisfaction in it.
There's so many jobs too, right? I mean, you can work in a shop, right? I mean, I went to a different school, but I went through a program similar to yours and went right into being an application engineer. You know, you can be an application engineer for a machine manufacturer, for a cutting tool company. You can be a consultant. You know, I mean, you can start your own shop, right?
Tool sales, machine tool sales, installation. There's field service. There's you know, management for some people. But yeah, there's, you know, I like to say that no matter what you like to do, whatever your skill set is, we have a place in manufacturing for you. I mean,
and if it leads to you going back to a 4-year university because of what you've discovered about manufacturing and machining, so be it. Go get that engineering degree if that's what this triggers for you. Great. That's the whole point of life.
I mean,
find what you want to do.
I mean, I've been doing this, it's crazy to even hear myself say it, but for 40 years now, and I still think there's something magical about being able to take just a piece of raw material and kind of, like you said, seeing the shiny parts come out, but like being able to make something useful out of that raw piece of material. And I mean, I'm still amazed at it. I'll go in on a weekend and I'll make myself something that I need.
Yeah.
And it's just I'm amazed. I'm like, that is just I did that, and it's so cool.
Mm-hmm.
But and speaking of the number of jobs needed, I'm finally starting to see signs where I do think the ship is starting to kind of turn around, and you're starting to see. We partner with one of the high schools that are sending students to us twice a week,
Oh.
and take welding classes. And
Who's
so Barrington.
Barrington.
And so we did a pilot program with them last year. We started with 20 students. Every Tuesday and Thursday they would come in, and they were able to complete 4 college classes in one high school year. And so that's huge. And some of these kids had, like, they'll be the first generation of their family to take any college classes. They're doing it for free. They're getting real college credit. And what was very heartwarming to me was, like, at the end of that at the end of the year, at the end of their 4th welding class, some of these kids had some real skills already, and to see the look on their faces, like, I've never built anything. I can't believe I'm doing this. And so now we're in the 2nd year with them, and next year we're looking to expand the offerings from welding. We'll still have a cohort for welding, but we're looking to expand that into machining classes as well. And instead of just being offered to seniors, we're talking about being able to offer it to sophomores, so they can come in for 1 year and do machining, 1 year doing welding, and then maybe their senior year either take advanced classes either in the machining or the welding program. And I mean, to me, it's such a great opportunity for these students, because now they graduate high school, they've got maybe a basic certificate that they've earned, and now they come back and they've got maybe close to halfway being done with their associates, and they come back for a year and they're done.
Yeah.
I think this leads into one of the next Bourbon with the Editor podcasts. Aaron, your boss, Kurt.
Yes.
Full
Kurt-
name and title?
Kurt Bilston. Yeah, he is the program coordinator at Harper for the welding program, the advanced manufacturing maintenance, and the ELT, the electrical program. He's been there a long time, but he's also got he has a ton of industry experience. He has a ton of, like, I feel like he knows everybody in the area, and he's just a wealth of information. And we would love to sit down with you and just talk about education and the state of the manufacturing industry, and what we can do to help and what we can do to recruit. And
that's going to be one of the next podcasts that we do. So look for that to come up within the next month or so.
Yeah.
I think would be good to get the word out about careers in this industry, because it's, I mean, if you're wondering what to do, if you're not interested in college for the moment, you would do a lot worse if you never tried a career in this industry. You'd be missing out on a I don't know how to describe this exactly, but it's such a creative outlet. It isn't just working with your hands. I mean, it's seeing something created right in front of you.
Yeah,
that you
well,
had to map
there's a
out.
lot of, I'm not quite sure how to put it. There's a lot of skill and knowledge involved, and unfortunately, there's still some old school counselors / advisors that treat our program as like a program of the last resort. And it's like, a kid comes in and he comes to Harper, and it's like, oh, I'm going to take chemistry, or I'm going to do this or that, and they don't do well. And it's always, well, you can always go into manufacturing because they'll take anybody. And unfortunately, and I've actually had quite a few discussions with some of these advisors, but I want that student that tested into whatever college, into their engineering program, but feels like they don't want to sit behind a desk. But I need that knowledge in the shop, and because it's not just pushing a button, and it's that there's really a lot of, I think it comes down to problem solving, and whether it's working with Will, problem solving from a tooling aspect, but it's also from point A to point B, is how's that part going to go through the shop? Because it's, as we saw in this podcast series with Vargus, it's not just a one and done and the part's done. In a lot of cases it could be that part could visit 4 or 5 different machines and have different operations before it's done. And I need that person that can problem solve and not only figure out the best way to get that part through the shop, but how are you going to balance that and get other parts through the shop at the same time in the best manner? And what's the best way to hold it?
Yeah.
What are the best ways to program it? And what are the best tools to use? I mean, there's so many variables, and how are we going to inspect it? There's, it doesn't do you very good to be able to make a part and then not be able to measure it. So,
Well, I mean, even in this application, I mean, we designed this part for this series, but this part went through 2 different machining centers. You had to do custom work holding for it on the mill, right? You had to build a riser for the tailstock, and you had to build a faceplate for the chuck.
right.
So, even for a simple project like this, you had to completely engineer your own work holding. And, it's a great opportunity to have a lot of highly physical work for somebody who doesn't want to sit still, and also get a ton of mental stimulation and satisfaction from your job, because every day you leave, you've actually completed something. You've seen the tangible results of your efforts.
That's,
Yeah.
to me, that's huge.
Yeah.
Yep.
Yeah, and you get benefits.
Yeah.
This is a real job.
Comes
people.
with
It's
dental.
a real career.
Comes
This
with
is
dental,
a
yeah.
real career. So, anything more? I was gonna say in next month in November we are gonna have scientific cutting tools. If you don't mind my saying that, this isn't the last time we're gonna have Vargus out here either. We will be visiting with them again. I'm not sure if we will do another project or not, but it is. This has been a great experience for me, and hopefully for any viewers out there and listeners, for learning a little bit more about what it means to have an applications engineer come out from a company like Vargus and help you figure out how the best way to use your that cutting tools that they're providing. This was not an actual pump shaft part. As Will mentioned to me earlier, it'd be a lot longer for oil and gas purposes.
Yeah, 40 times longer.
But it gives you an idea of how this whole process works, and I think hopefully we've done that well enough to inspire some thoughts out there in the industry about maybe changing up the way you've been used to doing things all along. So there's always a way to improve.
Absolutely, and for us too, it's been a great experience, and thank you for giving us an outlet to demonstrate this process.
Aaron,
And
thank
Aaron
you.
for a place to do
Well,
it. Yeah.
well, and thank you for including me. Like I said, I'm open to doing other projects, and I'm always I'm always willing to help. I try to be the best cheerleader I can as far as when it comes to, not only our program but just the industry in general. Like I said, I kind of fell in love with it at a very early age, and it still excites me as much as when I first got into it. So.
I can see why. I mean, I just, the whole thing is, this industry is such it's so fun to be part of, covering it. I scratch my head all the time about why people don't know about this as a career option, but then I learned from Harry Moser why, and Terry Averson's kind of explained, it was kind of shunned upon, and I guess I did sort of live through that when I was going through high school. So
Yep.
I get it, why it's in the state it is right now. It's been off people's radar for a long time,
Mm-hmm.
3, 4, 5 decades maybe.
Mm-hmm.
And man, do we need the help. That's all
Yeah.
I can say. So thank you again. Cheers. I'm
Thank
out
you.
of the bourbon
I
for
am
now.
too.
Cheers to you.
Cheers.
Cheers.
Thanks again. And Joe and Josh, I know you're not here, but thank you so much and for all the effort. And hopefully we'll see